Hello, good morning or good afternoon everyone, depending on where you're joining us from of course, and welcome to today's webinar. My name is Tarek O'Dali from Business Review Webinars and I will be your host. It is our pleasure to have Huawei with us today, who'll be presenting this webinar titled Cloud Native Technology, Evolution, Reality and Progress. Today's guest speakers are Akik, Senior Consultant, Cloud Communication Marketing Support Department at Huawei. We have Phill, Zhang, Chief Cloud Native Product Management of Core Network Product Line at Huawei. And of course, we have Zarich, Chief Analyst at Global Data. You're going to be hearing from them in just a moment. First of all, though, I'd like to welcome you to our webinar platform. This is on 24, and it's fully browser-based. So if you do disconnect for any reason, please just click on the link that you received via email to rejoin the session immediately. All of the icons along the bottom of your screen are the interactive widgets that we have on offer today, so please interact with them all throughout the session. You can ask questions using the Q&A widget or by using the questions box at the top left-hand corner of your screen. We'll try to get through as many of your questions as we have time for once the presentation has concluded. Please use the yellow Help widget if you do experience any technical difficulties or require any more assistance. You can also move, resize, and maximize any of the windows in front of you to get a better view of the slides if you need it. But now, without any further ado, please allow me to welcome our first speaker. Peter, over to you.
Thank you very much, Tarek, and thank you to everyone who is with us today. I really appreciate you all taking the time, and I appreciate and thank you to Huawei for having me join this webinar around cloud-native technologies. We've been doing a lot of work at Global Data around looking at service providers and their transition to cloud-native technologies. And what I'd like to do is to kick off this webinar before I hand it over to our friends at Huawei to talk about their solution. I just want to talk a little bit about what we're seeing in the market, where we're seeing the demand, why we're seeing demand, and what is moving the market forward. Talk a bit about really the timing around cloud native that we've seen working with our customers in the service provider side of things, and looking at customers on the vendor side of things, but then talk a bit about why, right? What's been the big buzz you hear from Huawei around their solution, but taking a step back, why do we see the market moving towards cloud native? And then finally getting a little bit more specific around the timing on how we see it rolling out and where we see it in its life cycle. So that'll take us probably through the first 15 minutes or so. Then I will hand it over to the Huawei folks. In the meantime, please, we plan to end this with some Q&A. So if you can use the Q&A widget to enter some questions, I think as Tarek mentioned, it would be great so we can address those at the end, because we're really excited to make this at the end a discussion as well. So moving on, when we started seeing this, I think, and in terms of the discussion around cloud native, obviously it's a big buzz now, and I call it a buzz. I think oftentimes you see this referred to as hype, but I think hype has a connotation that it's not real or it's not important, so I'm going to refer to it as buzz. And when we saw this around the service provider side of things, the communication service provider focus, I remember back in 2015 when I was at one of the first OPNFV member conference, and I moderated a panel with a number of startup vendors, and the discussion around cloud native came up around containers. Right? I don't think we were even calling it cloud native at the time, right? But we talked about containers. We talked about the interest in moving containers and how OPNFV was going to integrate that. It was very early days, and I think a lot of the service providers didn't fully understand why they needed containers. But we saw that discussion starting to take place around service providers. And I mentioned the service provider side of things a number of times because I think it's important to recognize there is a difference between the way cloud-native technologies like containers are being used around service providers and the IT or enterprise space. There's specific needs around how these get rolled out in terms of where operators are looking at their networks. So that's how I'm framing it here, right? So we saw this discussion bubbling up in that time frame, right, in that 2015 time frame. Then if we looked at last year, right, if we looked at last year and we looked at the discussion taking place in the industry, and this is an excerpt from a report that we did following SDN World Congress last year, it was really clear that this was becoming the mantra, right? Everyone was talking about microservices. Everyone was talking about cloud native. We began to, at that point, begin to look at how cloud native ready were vendor solutions. A large part of what we do at Global Data is look at vendor portfolios, how they compare their capabilities, how they rank in terms of being able to support operator needs. And at that point, everyone was really talking about it, and we could begin to do some comparison of how those solutions matched up. Now we're in 2017, and in 2017, really, it's gone from this buzz, right? It's gone from this, okay, everyone's talking about it, to being a little bit clearer, but also getting to the point where everyone's jumped on the bandwagon, right? We now have everyone jumping on the cloud-native bandwagon. We have lots of different definitions. Some are very vague. Some are very well-defined, but it's sort of all over the place, and we're at a place now where we're beginning to see that definition come into shape, right? We call it crystallize, as we talk about in the report here. We're beginning to get an idea of really what the solutions look like, really how vendors are looking to deploy cloud native, and what operators are looking for. So I think this is the right time to talk about it, since we're at the cusp of cloud native really moving forward, particularly in service provider networks. So the question then is, really, what is cloud native? And going back to this idea that we're beginning to see the definitions crystallize, we're beginning to see some real ideas about what it means. What does it mean in general? And again, we'll hear more from myself in just a second or so. We'll hear more from Huawei as they discuss what they believe is important in a cloud-native solution. But from our perspective, the basics are fairly simple, right? The cloud-native concept is simply building and operating functions, not from the NFV perspective, where you might just take functions that you've had and throw them onto a VM, but building them from a cloud-first paradigm, and then leveraging all the capabilities that you can get from a cloud-first paradigm to deliver more efficient, whether that's more timely, whether that's in terms of how you operate your network, but more efficient and more robustly capable networks than just repurposing legacy functions. So what does that mean specifically? And when you hear people talk about cloud native, how do they generally think about it? Really, when you hear cloud native brought up, there's three key technologies that are most often considered as key or critical to what it means to be cloud native, right? Containers, microservices, and some sort of distributed management orchestration function. It's almost no conversation, despite the fact that there's a lot of difference in how vendors and how operators talk about it. Despite those differences, these three attributes are fairly common across them. And there's a reason for that, because they're all important, right? Containers, if we think about the use of containers are important for really the idea of an efficient deployment and operation versus VMs, right? So versus the idea of using those virtual machines, looking at containers as a way to actually get the functions deployed, to actually operate them and manage them, particularly now that we have most of the management platforms looking to integrate them. That's the cloud native concept of why we're looking at containers. Microservices go hand in hand with them, right? And there's a lot that also goes hand in hand with this. You can think about stateless functions, right? The stateless operations of all of these. But microservices become particularly important then, because if containers are about the deployment operations, right, microservices are really about the development and scaling of those functions. I think it was a great example that I saw at SDN World Congress, for example, where one of the vendors was showing that if you needed to upgrade in real time or roll out, for example, scale up your capabilities around session border control. From a microservice standpoint, you may be able to simply upgrade the components of that SBC that require more capacity than the entire thing. The idea being that you can do it faster, you can do it more efficiently than upgrading the entire function. And then by doing that, you can scale those much more efficiently. At the same time, you can develop them much more efficiently to operate for the cloud infrastructure. Finally, talk about distributed management. right? Obviously, I think as we've learned, and I think the intersection of management and orchestration and cloud native functions sort of is a recipe for disaster to some extent, to the idea that mono has been poorly defined in many parts, and if you take that mono concept with potentially a vaguely described idea of what cloud native means, you could be in for disaster there when you take two different sort of vaguely described spaces. But here, and why this distributed notion of management and orchestration and operations of those functions becomes particularly important on the cloud native side, is this is where it becomes important for onboarding, for scale, and particularly for architecture support. We'll hear more from Huawei in particular, but the distributed notion comes in here when we think about future networks that won't just be looking at cloud in terms of one monolithic cloud, right, where all of your functions are in one big data center or 3 or 4 big data centers, but where you need to be thinking of your network in a much more distributed manner. And that's where you end up needing much more capable orchestration and management capabilities to actually bring those functions on board, to scale them across those different locations where you're actually rolling them out. So with this said, having a basic idea of what we mean by cloud native and sort of looking at where we are today in terms of the evolution of how it's being discussed, the question is, okay, so when are we going to actually see it? When do we actually begin to expect to see cloud native make its way into the service provider network? And here's where I'm going to break it down into two different ways that we can look at the market: supply side and demand side. Right. So from a supply side perspective, as I mentioned, we do a lot of work with vendors to look at their portfolios and how they stack up. This is a excerpt from a report that we did earlier in the year where we compared the solutions from a number of leading vendors in terms of how they're looking at cloud native. And we found is that across the board, if we looked at how they are thinking about cloud native solutions, we're looking at how they've rolled out the capabilities. And there it's really largely about messaging, right? Messaging around how they're thinking about the brand, messaging about the architecture and the solutions that they have for microservices around stateless processing, around container deployment, the messaging as well as how that's tied to their solutions. Again, we saw that it's fairly much across the board. I use this as an example, not just because this is a Huawei webinar, but we saw is that some vendors have been talking about, like Huawei, having come at development of their solutions from a cloud data perspective really for the last several years, right? Talking about that. Others, are talking about taking maybe a different view of look, clearly there's some things that need to be cloud native. Oracle, for example, though, talks about the idea that, some functions might perform well just as purpose-built appliances, right? We don't need to go cloud native. And clearly, a vendor like Oracle obviously is going to be supporting cloud native capabilities as well, given their focus on the cloud. But the one point that comes away is that from a supply side, from a vendor perspective, all of the vendors now have some sort of cloud native story, right? So for any operator looking to embark on a cloud native journey, the vendors are all largely ready to help them move in that direction and start supporting them in that. So that's the supply side of things. But the question is, where is the demand coming from? And are we seeing operators who are going to be driving this, and why? And on the first side of things, I think we're seeing the demand come from the fact that like much of what drove a lot of the network transformation taking place in the service providers right now, we still see this focus on what's taking place with, let's say, cloud players, right? Whether it's the pure cloud players, Google, Amazon, Microsoft, or whether it's the idea that there's innovation from, as we often call them, over the tops, right? There is this idea that demand within service providers is being driven by a need to better emulate what they're seeing from pure software and cloud players. And again, this highlights the difference, right? The difference between cloud native, let's say, on an enterprise side of things versus the service provider side of things. But we're not seeing this slow down, right? As we see enterprises move towards the cloud, as we see the OTT and web players really ramp up their competition with the service providers, we see this need from service providers to want to better develop their networks, better architect, upgrade their networks, evolve their networks to be more efficient. and that's helping to drive a lot of what we're seeing on the cloud native side of things. But at the same time, we're seeing some major changes take place, right? And we all know the changes that are taking place in operator networks, but here's just one example, right? The idea of 5G coming forward, right? And we know that 5G used to be seen as a 2020 phenomenon. That's how we all positioned it a couple of years back. We also know that that's not the case anymore, right? That we're going to start seeing some form of 5G in trials around major events next year, like the Olympics in Korea, like the World Cup. We know we'll see that pushed forward in 2020 with events like the Tokyo Olympics. But before that, in 2019, we'll probably see the first launches. And in tandem with that, as operators think about rolling out that part of their network and those upgrades, that's an opportunity to think about re-architecting their network in the core, thinking about how they integrate cloud native. And are we seeing that in reality? I mean, is this thinking really something that we actually see as operators look at? Well, when we take a look at a couple big industry initiatives, that is exactly what we're seeing, right? You think about things like CORD, as we see operators move on the CORD concept, central offices re-architected as a data center. We see a couple things there, right? This idea of disaggregating the network, which goes back to that idea of distributed mono being important. We see the idea of how is it possible to look at that as a platform for containers and microservices as opposed to just VMs where we may have been a couple of years ago. Likewise, as we look at things like ONAP, which has a lot of support from operators, and you can see the list here, we see ONAP also moving to integrate containers, microservices in the architecture, right? You saw that with, we saw the most recent release, the Amsterdam release taking place. We know that there's a project within it for Kubernetes. We also see ONAP being implemented in Docker containers. So to that extent, we really see the industry coming together, the pieces coming together in line with the rest of the demand as we would expect. So with that said, I'd like to say thank you, everyone. As I promised, take about 15 minutes before I hand it over to the Huawei folks. Before I do, though, before I hand it back to Tarek, just one last reminder, please take the time if you have a chance and you have any questions to go and enter some questions into the Q&A. I see that we already have some, so that's great. But any other questions that you all have will help to make for a great conversation, a great discussion afterwards. So Tarek, let me just hand it back to you.
Thank you very much, Peter, for that excellent presentation. And now, audience members, I'll hand you over to Akik from Huawei for the next part of this webinar. So Akik, over to you.
Thanks, Tarek. I want to start highlighting the reasons behind the requirement of cloud native for telco domain before I dive into technical details, so that we can understand the equation why it's the subject of increasing interest of operators as a design and implementation concept during their network transformation. I want to identify two radical changes in a telecom domain as the main drivers behind cloud native adoption. The first is the rapid development of 5G and the new ICT convergence services. What we see, augmented and virtual reality services, Internet of Things are gradually moving from dreams to reality, and telecom services are becoming more abundant. The traditional business-to-consumer model is being supplemented with a business-to-business or business-to-any model. Operators are wishing to mine value from the long tail of niche demand. Secondly, IT-grade POS hardware is gradually taking place in the infrastructure layer. You know very well that this IT-grade hardware is much weaker than the traditional ATC-grade hardware in terms of performance and telco-grade reliability. So these two changes are pushing telco software, or you can say the network functions, to adapt with, firstly, underlying IT infrastructure, and secondly, meet the demands of diversified industries and experience at the same time. The question is whether they are able to do that. Typical virtual network function that we get after simple virtualization by decoupling the software and hardware simply cannot fulfill the upper layer service requirements and cannot make up the gap that is brought by this IT-grade infrastructure hardware. To meet this gap, here comes cloud native. Cloud native is it's a combination of the architectural design philosophy and technologies. It is supposed to address this situation well. It enables virtual network functions to adapt itself with underlying IT infrastructure and ensure a diversified business experience, providing necessary resilience, flexible scalability, and obviously innovation agility to meet the future 5G business development. But now, while understanding these IT-based practices for the city domain, there are many wrong concepts regarding cloud-native terminology, as Peter was saying. Many considers virtual network function decomposed further into microservices as the cloud-native, which is in fact one of many key elementary technologies of cloud-native. Cloud-native is an IT concept and practices that involves a series of key technologies and best practices to restructure a telecom cloud networks like it's a stateless design, microservice architecture, containers, the DevOps platform, smart operations maintenance, and so forth. To understand it more clearly, we can broadly categorize it into 4 categories, as you can see in the slide. It's a stateless design, service-based architecture or decomposition, automation, lifecycle management, and container deployment. Each category includes one or multiple key technologies, as seen in the slide. However, it's not meant that all of these technologies be introduced in a single big bang upgrade. The commercial realities, feasibility, and benefits must be carefully thought in the evolution process. Operators need to study about the market demand for service quality alongside different demands on development and operational model, depending on the application use case. With the elastic, robust, and agile model in mind, they will have to gradually evolve in response to evolving needs. So in short, it's not the technology, rather the business value that drives the cloud native. And it's not picking the right technologies, rather it's picking the right technologies rather than the most advanced technologies, case by case. So in the following slides, I and my other speaker will try to explain in brief the cloud native pillars. Let's start with stateless design or stateless architecture for VNF. VNF virtual network function decomposition starts from a vertical decomposition to ensure the stateless design. That's why it's called the cornerstone of the cloud native architecture. The code and data are separated. Service states and the session that are stripped out from the processing unit for virtualized network functions and stored in an independent distributed database, so that the VNF processing unit itself is completely stateless. You can see 3 layers like a database layer, a process layer, and a load balance layer. Each layer works in N-way mode. N-way mode is not active standby, rather all modules in each layer in active state and also in parallel and decentralized. Each layer can be configured with a different level of redundancy individually. A trouble in one particular module in a particular layer will not bring the whole system down. Rather, the module's task, the problematic module's task can be taken by other active module without interrupting the service. And even you can do the scaling in or scaling out. You can do it individually on each layer. So the most important thing here, this architectural design makes the system is multi-fault tolerant. Let's move to the next slide. We talked about the vertical decomposition, and this is what the horizontal decomposition. Horizontal decomposition or service-based architecture is it's essential for agility and future 5G. SBA, service-based architecture, is under development in the 3GPP's technical specification, particularly it's TS23.501 working group. And 3GPP standards work is currently ongoing as a part of release 15. It will be scheduled. It's scheduled to freeze by mid-2018. So in SBA, VNFs are horizontally decomposed into multiple service modules, also known as microservices, which are self-contained, reusable, scaled, and healed independently. A combination of, I'm just trying to explain it, a combination of these service modules make a particular network function, and a consolidation of multiple network functions on demand provides an end-to-end service over, obviously, over standardized APIs. So an operator can easily add, remove, or modify these service modules, what you can assume as functional agility, and then create a new service on demand that we say service agility. So what we understand, an end-to-end network service made up of some network functions, where each network function contains many service modules. Network function and service modules communicate each other over service-based interfaces, which are currently under development in 3GPP. The service modularity as per a service-oriented core SoC architecture is visible in Huawei solution right at this moment. The difference between current solution architecture and SBA is, for SBA, 3GPP has a definite function definition, like access and mobility management function, EMF, policy control function, PCF, and so forth, and has also a standard interface definition. As the architecture is ready in Huawei solution, the upgrade from current architecture to SBA will be very smooth once the interface is published. Just need to group the modules to form a particular defined function, and wrap it up with a standard interface as 3GPP defines. Huawei and China Mobile has already tested this SBA architecture for 5G core, and will move on to multi-vendor testing in 2018, next year. So in Huawei solution, the modular decomposition and on-demand consolidation is already visible in reality. On-demand consolidation of components from module library makes new VNF or services under orchestration and independent slice management, which customers right now are enjoying at NFV Open Labs since last Mobile World Congress. Here I want to say something about this microservice. Although microservice is one of the key technologies for realizing agility, they make the services more flexible, but the system pays a price in terms of performance and an increase in the number of potential points of failure. So therefore, operators should introduce microservice architecture as and where required by the specific application and network model. There are very good understanding in the market in the sense that microservices can be introduced first for application which typically require fast changes and extensive customization like Internet of Things, policy controls, etc. More and more services will follow the trend naturally with the development of the 5G core. So that's all about the VNF architectural design, and let's talk about the network topology. Okay, so we vertically decomposed the virtual network function into stateless modules. Then in the service-based architecture, we got VNFs decomposed horizontally into service modules, which are consolidated on demand to provide end-to-end service. But challenges like growing demand of massive bandwidth per subscriber, high latency, fast growth of network connections, how will we meet these challenges? Here comes CUPS, control and user plane separation. A 3DPP defined control and user plane separation principles to solve these problems. It obsoletes the practice to deploy gateways in central network. Before the CUPS architecture is applied, gateways like signaling gateway, S gateway, P gateway, like the PDN gateway, are usually deployed in central networks with MME. MME means a mobile management entity. And this deployment scheme can hardly meet the demands for higher capacity, performance, and obviously the various types of service slices. Now, to apply CUPS principles, control and user plane functions of both S gateway and P gateway are separated, and then control plane part of both gateways are deployed in central network, and the user plane part of both gateways are moved down to regional networks. Content sources are moved down with the user plane anchors, so thereby shortening the distances to content sources, reducing the latency and improving service experience. In SBA architecture, in service-based architecture, it's much easier to realize in the network. As 3GPP defined after SBA decomposition, it becomes some particular true functions like SMF, the session management function that contains actually the control gateway function abilities, and UPF, user plane function that contains the user plane gateway abilities. So SMF and the UPF can be instantiated on demand in control plane or in user plane much easily. And gateway functions at user plane will be able to serve low latency applications hosted in edge locations efficiently. So here, I want to put one case. I want to show you one case. This case is a classical example of CUPS deployment, as you can see in the slide, vehicle to any communication application at local user plane. It's a SAIC. SAIC is Shanghai Automotive Industry Corporation. It's a Fortune Global 100 company. China Mobile, SAIC Motor, and Huawei Technologies jointly showed the world's first 5G-based remote driving technology with a consumer car using the C-band frequency at 2017 Shanghai Mobile World Congress. Huawei, in this case, Huawei provided the 5G wireless solution that connected SAIC Motors' smart concept cars. It's an MG brand car with China Mobile, while China Mobile provided the connectivity. So in the test, the driver was located over 30 kilometers away from the vehicle. Several high-definition video cameras installed in the vehicle sent multiple real-time high-definition video feeds to the driver remotely, providing him with a 240-degree view of the vehicle's surroundings over a 5G network. control signals for the steering wheel, gas pedal, and the brakes were transmitted over the 5G network, which provided the ultra low latency. Required to support instant response to different roadside conditions. From remote position, the driver was able to maintain full control over the vehicle at all times. In this particular test, excuse me, end-to-end latency for all vehicle control. I apologize. That end-to-end latency for all vehicles, it was less than 10 milliseconds. So remote driving, it has a broad range of potential applications in the future. So by this time, we already came to know about stateless design, service-based architecture, and control and user plane separation. Now I will hand over mic to Mr. Phill to discuss about the rest pillars of cloud native. Mr. Phill.
Thanks, Akik. Okay, as explained in the previous slides, cloud native has 4 technology pillars. One is the microservice-based, one is the stateless design, and the other 2 are containerization, or we say new infrastructure, and another one is lifecycle management, or automatic lifecycle management. So when it comes to the infrastructure, new infrastructure or container, for sure it's a hot topic now, and we all know that container comes with it's a much less overhead compared to virtual machines, and it's more agile, so more easily to be started up and shut down. So and at the same time, it comes with some security issues because all the containers share the same operating system kernel. So in case one application panics, the other applications will suffer from that. And another one, when it comes to the telco, we need to address is the difference between the telco applications and IT applications, because telco is more network intensive. So like the multiple network plane support is a mandatory requirement. And we need to be able to orchestrate the different containers based on the different application requirements, like the large page or CPU binding. All of these key features are very important for telco applications. And these points are something still being addressed in the industry, and we see some progress, but still it's not ready for commercial deployment. Another one attribute of container is the agility it brings, because it brings the consistency between build, ship, and run. So it's one of the best choice for the automation. So taking all of this consideration into account, we see containers are very promising. And so that's why Huawei is actively investigating on this approach. At the same time, we also need to think about it in the commercial readiness point of view. So we think in a long run, container is one of the approach. And at the moment, still a lot of job need to be done in the industry. And when it comes to the deployment, we think the edge data centers might be the possible early adopter, because over there you can benefit from the efficiency, and you have some constraints on the resources. So we see edge data center might be the early adopter of there. And for the other areas, it will coexist and in the target network. That's it. So this is deployment. When we come to the automatic lifecycle management, we need to know that when it comes to multiple microservice, and each microservice is delivered more fastly than that before. So our current approach to have this deployment or the acceptance test, all of this preparation procedures has to be adapted as well. That's why Huawei provides the whole solution. We call it NICs-based DevOps. It's NICs stands for Network Integration Craft Suite. With this, so each new software release from R&D, as you know, it's getting much faster now, will be delivered to the premise of the customer's premise. Over there, the Huawei NICs platform can automatically trigger the CSM, Huawei's own manual or VNF manager, to deploy the specific EU2000 Huawei EMS and the relevant VNFs. And all the configuration of these VNFs will be performed automatically. And after that, our NICs platform will initiate this upgrade of this VNF and make some test configuration and conduct the test automatically. And all of the test results will be traced and reported. And so in case some problem happens, it will provide necessary information for troubleshooting. And this bug report can be looped back to the development team. So finally, you will have end-to-end DevOps process. This is one of the major efforts we have done to support the more frequent system upgrade. Now it comes to the question: how can we make sure the VNF can be upgraded automatically and risk-free and more easily? So that's why we provide the solution which is called Agile ISU, as you see from the desktop. It means Agile In-Service System Upgrade. Because in most cases, the operators have this kind of dilemma between the marketing team and the operation team, because the marketing team is more keen to have new releases more fastly to address the new market requirements, but the operation team more prefers to be let it more to be stable. So, Huawei provides a solution where we can support the individual modules upgrade independently, and each individual module can be upgraded in a graceful manner. So the users can be migrated to the new version of this microservice more gracefully, so without service loss. So this is one of the key features we think is more important for the cloud native. After that, it comes to operation. So we think that it will be divided into three phases. One is simplify the NFV. The second is automatic NFV operation and maintenance. The third is intelligent NFV operation and maintenance. That means we are going to address the different challenges step by step. Take this for example. For the last one, for the second one, in the closed loop driven automation, you need to define the threshold manually. After this definition, you can have this automation. But when it comes to the third phase, all of this threshold can be decided by the artificial intelligence or the big database. Yeah. Okay, may I hand over back to Akik for our marketing presence?
Thank you, Mr. Phill.
Okay.
We are at the last section of this webinar session. While talking about the industry progress in commercial deployment, we have seen significant momentum in network function cloudification with cloud native. While talking about Huawei being a leading telecom solution provider, Huawei pioneered in the industry, providing a cloud-native based solution across all tier operators. Huawei has incorporated cloud-native principles into its NFV solutions from the start of its development. It adopted vertical and horizontal decomposition for all core network VNFs. While talking about operators, tier 1 operators obviously have been very ambitious to carry on projects and joint innovations with vendors to deploy and test a range of cloud-native products and technologies. To talk about the Vodafone, apart from cloud-native based commercial case in multiple Vodafone network, Huawei and Vodafone's joint innovation and verification hold a significant importance to drive cloud-native technologies into maturity. This operator-vendor joint innovation effort has been verifying container-based deployment as well as the A/B test or ISSU, just now Phill said, on multiple cloud-native core VNFs. Vodafone Spain rolled out world's first standard NB-IoT network commercially based on microservice-based Huawei solution. Deutsche Telekom implemented the world's first autonomous network slicing on an end-to-end Huawei 5G system. Huawei's next generation modular and programmable cloud-native core was a part of this solution. Huawei's cloud-native core solution enabled this case to implement use cases of multiple slices like ultra low latency applications, ultra high throughput applications, and normal MBB applications on one physical network infrastructure where control and user planes that were separated and distributed in multiple tiers. To talk about the British Telecom and Huawei partnership also got engaged in joint innovation to verify agile cloud-native core for dynamic network slice and next generation data plane. Switching to cloud-native based Huawei Cloud PCRF solution commercially in December 2016 was a significant drive to British Telecom's network transformation. On the new network, the average time for introducing new control policies was cut from 3 months to 2 weeks. China Mobile and Huawei jointly showcased the world's first 5G core network prototype I mentioned earlier on service-based architecture at 2017 Shanghai Mobile World Congress. The prototype adheres to 3GPP's 5G SBS standard. It has won extensive support from the industry and has been recognized by 3GPP as the standard architecture for 5G core networks. Besides Telefonica's large-scale Huawei cloud-native cloud EPC deployment over Unica, Telecom Argentina's massive end-to-end core network transformation is another significant push to network transformation in Latin American networks. Huawei's Nix tool, that's Network Integration Curve Suite, that just now Phill introduced. This was used in Argentine project to automate network design, test, and deployment. Beside China Mobile and Psych Motors example I mentioned earlier, there is another case I want to mention is China Telecom's Ningbo network, where CUPS was implemented commercially with Huawei mobile edge computing solution and service containers were deployed over edge network. So overall, it's a positive sign for both operators and vendors. Obviously, tier 1 operators' active engagement with leading vendors will play a significant role to push the market into a more maturity. So here I summarized the whole session. In this webinar, we discussed about the technology pillars of cloud native in connection with Huawei progress and vision. VNF decomposition is done vertically and horizontally. Vertical decomposition ensures a stateless architecture, which is considered the cornerstone of cloud native architecture. Then horizontal decomposition through service-based architecture is a business-driven modularity. This is actually architectural readiness. Then comes distributed agile infrastructure readiness. After a VNF decomposition, control and user-plane functions are separated in a distributed architecture to ensure better experience. Decomposed service modules are deployed over container or a virtual machine, or container over virtual machines as a situation demands. This is about the second key readiness. Okay, and then how the decomposed service modules are developed, upgraded, updated, tested, deployed in an automatic fashion, a continuous integration and continuous development under vendor operator DevOps environment, smart operation maintenance, and so forth, are all to ensure the third key readiness or automatic lifecycle management. We are helping our partner operators to drive their network transformation as well as doing joint innovation to ensure the network readiness for 5G. So that's all from my side. Thank you all. I am handing over mic to Zarich now. Zarich.
Brilliant. Thank you very much. And now it's the start of our Q&A session today. So audience members, if you do have any questions, please send them in via the questions widget. Just type them into the box there at the top left-hand corner of your screen and click submit. So let's get to some of the ones we've already received so far. This first question says, when you talk about microservices, how does Huawei consider the size of the microservice?
Well, let me answer this question. Actually, we think the size of the microservice is determined based on the business driven. So, then, to what extent you define the microservice shall be conformed to the following three conditions or three principles. We think the first is it should be independently scaling. So it means it will have its independent resource requirement. The second is independent life cycle. That means upgrade. So you need to be upgraded independently. The third is this microservice is optional in some situations, not mandatory in all situations. Yeah. So we think should conform to the three principles.
Okay, great. Thank you very much for that answer. We're going to move into another question now. So this question says, is the microservice visible to the operators? That's, is the microservice visible to the operators?
Okay. We think as long as the microservice falls into three principles, they should be visible to customers, to operators. Otherwise, the other microservice should be within the vendor's own implementation. So, the answer is yes. But we understand this should be at the, let's say, vendor's specific VNFM or EMS, element management system. So it can avoid the complexity complexity between different vendors. Yeah, that's it.
Okay, thank you very much. Audience members, please do keep these great questions coming in. Don't forget, you can do that by typing them into the box there at the top left-hand corner of your screen. Click that submit button, and we'll try to get your question answered on the webinar. This next question says, since 5G involves new radio access network and new core components, what is the link to cloud-native technologies? Why do they go together?
Okay. Actually, 5G is the network that quite differ from the previous network because it is going to address the uncertainty of requirements with wide architecture. So that's why we selected the service-based architecture instead of the point-to-point or the protocol-based network. That means each network function has to be able to evolve independently. So the service, the API has to be self-managed, self-evolved. This, when you have to support this capability, when it comes to the implementation of this NF, it has to adopt this same principle. That means in the NF, it should be service-based or microservice-based. So you have the ability to provide new features very fast, and you need to keep the API in the contract way. And on the other hand, 5G comes with a lot of new, let's say, ultra experience, let's say 10 gigabit or 1 millisecond latency requirement, and it comes with the ultra diversity because each vertical market has different requirements, and you need to be efficient, very efficient. So our network architecture, our system should be able to decompose the user plane and control plane to put the right application on the right infrastructure so that you can have this low latency, like we put the user plane down to the edge data centers. That's why we think the microservice-based, stateless design, and the decomposition is the cornerstone for the 5G network.
Yeah, I would just add in from what we're seeing across our customers and across the market. There really are two components to the push on 5G, right? First is just the fact that if 5G looks to be a new network, this is an opportunity when a lot of operators, they see this is the time for them to rethink how they've architected their network. So they're introducing changes, let's say in the radio access network. They're going to introduce changes in terms of the core network. So moving to cloud native architectures just makes sense. But I think as we just called out, the other part is just the idea that 5G is seen as more than just a new network and a new access network, but also seen as a new opportunity to engage with different verticals and different markets, and to be able to address those markets quickly, right? The idea that we can spin up resources in a network slicing use case to support a specific vertical, you're not going to be able to spin up those resources quickly and in line with the customer needs unless you've architected the network to do so. And again, it's going to require things like cloud native.
Yes,
okay, great. Thank you very much for those answers there. And I'm afraid now that does bring us to the end of today's webinar. I'm afraid we are all out of time here today. So that just leaves me to thank Akik, Phill, and Peter for what was a great presentation. I'm sure you'll all agree. And of course, to thank Huawei for this webinar, for sponsoring it, of course. And now let's talk about what you can expect from us. So all of you will receive an email shortly telling you how you can access the on-demand version of this webinar. So keep an eye out in your inbox for that. Should arrive at some point tomorrow. Or you can access it from our website, which is www.business-review-webinars.com. We do look forward to sharing further webinars with you in the future, of course. So please keep an eye out on our website. Or you could just follow us on Twitter at BRWebinars for daily updates. And of course, feel free to join our LinkedIn group as well, Business Review Webinars, to stay up to date. Thank you all once again, and I hope you all have a lovely day.